Assalamualaikum dan selamat sejahtera. Selamat datang kepada guru-guru dan pelajar-pelajar ke program Guru Muda Maya SPM 2024 Fasa 2. Anjuran SMK Taman Maluri dengan kolaborasi bersama YPC International College. Peringatan mesra semasa program sedang berlangsung, pastikan mikrofon dalam senyap, pinkan nama wakil yang akan berbicara sebentar lagi untuk melihat slide perbentangan. Pastikan anda bersedia bersama buku catatan untuk mencatat isi-isi penting. Sebarang pertanyaan boleh terus bertanya di ruangan chat semasa sesi Q&A. Pelajar juga dijemput untuk mengisi pautan atau scan QR code yang disediakan bagi tujuan pendaftaran dan klik pada pautan yang disediakan untuk mengisi kehadiran anda. Untuk makluman pelajar, program malam ini akan diteruskan lagi dengan subjek chemistry. Oleh itu, saya mempersilakan wakil SMK Taman Maluri untuk meneruskan atur cara program. Dipersilakan.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Salam SMK Taman Maluri gemilang bersama dan salam CMM SMK TM YPC diucapkan warga Maya, khususnya kepada guru-guru dan rakan-rakan calon SPM 2024. Mencari timba si anak dara di bawah sarang burung tempur. Salam sembah pembuka bicara, selamat datang untuk semua. Selamat berjumpa secara maya, saya Putra Emi Iskandar dari SMK Taman Maluri dan pada malam ini saya merupakan hos anda bagi program Guru Muda Maya anjuran SMK Taman Maluri, Kuala Lumpur dengan kerjasama YPC International College. SPM semakin mendekati kita semua, jadi semestinya kita jangan alpa untuk membuat persiapan yang rapi seawal mungkin. Pada malam ini, Guru Muda Maya kita ialah Li Gianzi. Akan bersama-sama kita selama 1 jam untuk membincangkan topik Head of Reaction. Sepanjang siaran ini berlangsung, diharapkan rakan-rakan menggunakan ruang sembang secara berhemah dan jika ada sebarang soalan juga boleh tulis di ruangan sembang. Tanpa melengahkan masa, saya mempersilakan Li Gianzi untuk mengupas topik tersebut.
Hello everyone. Please give me a minute to set up the share screen. Right. Can you guys see my PowerPoint here? Right. Good. Before I start my class, may I know, have your school teach about this chapter, which is Form 5 Physics Chapter 3? May I know for a while? For Cochrane, yes. For Trishali is from Maluri, so Maluri also yes. Right. Sure. For today, I will straight away proceed to problem solving. For the basics, I will not talk a lot, but I will focus on the problem solving part. Okay. So this one is a subtopic of the chemistry chapter 3 in Form 5. Okay, so we are actually learning these 4 types of heat of reactions. The first one is heat of precipitation. The second one is heat of displacement. The third one is heat of neutralizations. The fourth one is heat of combustions. Actually, they are pretty similar, I have to say, but they also have some difference that how different they are, I will show you after this. The most important part is the end here, and I will talk detail about it after this. Okay. Right, this will be 2 formula that we will be using. But actually, there will be some basic formula like the formula for mole, the formula for molar mass, something like that. That one we will also be using, but there's 2 basic, so I didn't list out here. Okay. before I start the questions, right, there's two basic info that I think everyone have to know. So basically, exothermic and endothermic. We got two types of reaction, but today we will be more focusing on exothermic. When we doing exothermic, right, the heat will be released. Wait. Wait for a while. Because I heard somebody say that they cannot see my screen. So is it okay to see my screen here? Yes, all right. Okay, I continue. Let me proceed. Okay, so we got two type of reactions. I mean thermochemistry reactions. So basically, the first one is exothermic, and the other one is endothermic. The exothermic means the heat released to the surrounding. So basically, how does it work? It's like, okay, for example, this one is the reactant inside the water. The heat is released from the reactant to the water. This is what it means. So that means it will cause an increase in temperature. For endo, it will be another way around. Okay. Right, this one is the water, and this is the reactor inside. For endothermic reactions, the reactor inside the water will absorb heat. That means the heat will go into the reactant. So that means the temperature of the water will be decreasing. Okay, I guess everyone can understand this. This is the most important thing to know because you have to differentiate the exothermic and endothermic. This one is the most basic things already. Right. And also for the exothermic, right? Because the heat is released from the the reactant to the surrounding, that means the heat inside the reactant will decrease. So when we write delta H, right, we will write in negative. But for endothermic, the heat is absorbed, so the temperature inside, the heat content inside the reactant will increase. So when we increase, right, the delta H will be in positive. Right, let's proceed with the questions. Okay, here is the first question. Figure 3.18 showed an experiment to determine the heat of precipitations of silver chloride. Use the information given to calculate the heat of precipitations of silver chloride. Okay, so now there are a few easy given. So there are a few information given here, the specific heat capacity and the density of water, and also inside the figure, you can see a lot of info there. So basically, we are using the two formula given at here to get the answer. Sorry. Okay. The first one is Q equal to MC theta. If you want to know what is mean by the formula is Q mean the heat equal to the MC theta. M is the mass of liquid. Okay, and then C is the specific capacity. Basically, this one is the C. Okay, and then this one is the change in temperature, theta. Okay, so all the information here is actually given. So at here, we have to calculate Q. Now we have M, C, and theta. So we try to list out. Mass here is what? You can see, the mass is not given at here. But actually, the mass here is the volume. Why? because of the density of water is 1. That means in this case, right, the temperature, the density, the volume in cm cube will be equal to the mass in gram. So basically, the volume we want is the sum of these 2 cups of water. The mass we want is sum of these 2 cups of water. So 50 plus 50 is equal to 100 gram. Okay, for the specific capacity, it's already given here, right? So this one very easy. 4.2. For the theta, the temperature change, it's not given. You have to find it out yourself. How? Okay, you got here the final. There is the final temperature, 32. And this 2 is the initial temperature. But we got 2 different initial temperature, then how are we going to find it? So we got 2 different ones, right? You add it out. You add it up together. And what you get will be the temperature in between these 2. So how you find the temperature in between? You sum up 2 of them and divide by 2. So you will get 29. Okay, so this is our initial. You know that the change in temperature is final minus initial. So 32 minus 29. Then we'll get 3. Okay, so now we already get all of the value we got. 3. Okay. So now we continue with the formula. Q equal to 100 multiplied by 4.2, which is the C, multiplied by theta, which is 3. And try to tell me the answer. Try to type it into the calculator and give me the answer. My slide is frozen. Oh no. Okay, sorry. Can you guys see the slide? I guess there's a bug there. When I share screen, they cannot see the slide. But it's okay, I'll try to solve it. Okay, so guys, help me to calculate this and give me the answer in the chat box. Can anyone tell me the answer? 100 times 4.2 times 3. 1260. Okay, correct. Okay, so the answer is 1260 joule, because it's in the form of energy, so it's joule. But there's a case here. Normally, if you want to continue with this, you want to continue with another formula, right? The joule, we have to convert it into kilojoule. This is kJ. So kilojoule is actually, kilo means 1,000. So you try to divide it by 1,000. 1, 2, 3. Okay, so you get 1.26 kilojoule. All right, now. Okay, now let us continue with the second formula. wait. Ew. I cannot present it in full screen, so I think I have to make some adjustment. Okay, nice. Okay, let us continue with the second formula, which is given here. Delta H equal to Q over N. Alright, the Q we already know, which is this one. This one is our Q, 1.26 kilojoule. But what is the N here? The N will be a little bit more confusing at here. So before we get the N, we have to construct the chemical equation first. Okay, now we have the silver nitride. Silver nitride is AgNO3. And then we have the potassium chloride here, which is KCl. And then it will become AgCl plus KNO3. Okay, we balance it. I feel like we don't need to balance anything. Okay, just continue. So now you can see that we have the ratios of each of it is 1, 1, 1, 1. So that means that the mole of AgNO3 and the mole of the KCl is equal to the moles of everything, the mole of this one and this one. So how are we going to find the mole of the precipitate? Okay, what is actually a precipitate? Precipitate is actually the insoluble salt at here. So which one is the insoluble salt? Now, actually what are we finding is this one. This is our insoluble salt here. So this is the thing that will form the precipitations. Okay. Now, let us find the mole of this. But by knowing the ratio, right, we know that the mole of this one is actually equal to the mole of this or this one. So we try to find the mole of this one and this one first. Okay. The mole of silver nitride. Silver nitride is, okay. Now you got see 0.5 mole DCM -3. And you got 50 cm cube of the volume. This is the molarity. Okay, you know that actually the molarity from the unit, you can know that the molarity is the mole divided by volume. And you get 0.5. Right. So the volume here you already know is 50. 50, but actually, is it really 50? No, because it is cm. The unit we are dividing is dm3. dm3 is basically a liter. The cm cube is a milliliter. So we're gonna convert this one into dm. So if you convert, it's 0.05, right? dm cube. So now what we got is mole is equal to 0.05. 0.5. Okay, so what is the mole? Mole is 0.5 multiplied by 0.05. So the both side multiplied by 0.05 and then 0.5. So the answer you get is 0.025. Okay, here is the answer for the mole for this one. The mole for silver nitride. And what is the mole for this one? You can see all the value here is same as the value right here. So the mole is also the same. This one, so 0.025. Right. Okay. Now we got the volume, the mole of this one already. So as I said, the AgCl have the same volume. Sorry, the same mole. So 0.025, this one also 0.025. That means we already get the N. N is 0.025. So continue with the formula. Delta H equal to 1.26 kilojoule divided by 0.025. Try to give me the answer, guys. So what's the answer for this one? Hmm? Okay. I see got somebody say 50400 joule -1. Actually, the answer, before you continue with the second step, right? The unit you have to convert to kilojoule first. Because the answer in chemistry normally we want in kilojoule mole -1. Okay, so I already see the correct answer is 50.4 kilojoule to the power of kilojoule mole -1. Okay. Okay, actually we are not done in this step. Have you remember what I stated before this? Okay. For the exothermic reaction, which means the temperature increase, right? The delta H must be in negative. But now we written it in positive form. So we have to rewrite it in negative. So delta H is equal to negative 50.4 kJ mole to the power of -1. So this is our final answer. Can you guys understand? Right. All right. If you guys can catch it up, so I will continue with the next questions. Okay. Calculate the heat of displacement. So the displacement of silver nitride solution by copper take place based on the following equations. Okay, a student carry out these displacement reactions by adding 1.28 grams of copper powder into 100 cm cube of 0.5 mole dcm to the power of -3 silver nitride solution in the polystyrene cup. Calculate the temperature change of the solutions in the polystyrene cup. But okay, this question will be a little bit more complicated because he's not asking you to find the heat of displacement, but he is actually asking you to find the temperature change. But still the same, you will be using the same logic, which is the two formula that we used just now. Okay, So the first one is Q equal to MC delta theta. Okay. Now, in this case, which one is the M? Can anyone tell me which one is the M? M is actually the mass, but the mass of the liquid, the mass of the water is actually equal to the volume of water. So what is the mass at here? Anyone tell me? M is the mass of liquid, mass of water. But the mass of water is actually equal to the volume of water. This is the one of the things that you have to take note. Because the density is 1. That's why. Okay, so it's 100, right? Okay, good. So the mass is actually here, the volume. Okay, so it's 100. Multiplied by the specific capacity is given here. C specific capacity is 4.2. And the temperature change. This one is the thing that we have to find, so it's not given. So I write it here. Okay, Q, do we know that? We don't know yet. So we keep it. Okay, so when we continue the multiplications, okay, 4200, 420 only. Okay, so 420 theta. Okay, this is our incomplete heat because we haven't calculated the actual value. We write in the form in terms of temperature change. Right. So now we have to find Q. Okay. So we know that delta H is actually equal to Q over N. And the delta H is given at here. So 105 is actually equal to Q over N. But what is N? Can we find N for us to find Q? Okay. So just like just now, we'll be finding the mole of these two things in order to help us to find the mole of the 2Ag. Okay, this is the mole we have to find. But before this, what do we know? Okay, so we can get the mole of this one and this one first. Right. Okay, what is the mole of Cu? Okay, the mole of Cu, how can we find? It's given that the RAM of Cu is 64. So we straight away using the RAM and the mass given here to find the mole. Okay, so for mole, you want to get the mass, you will multiply by the RAM. If you want to get the mole by using the mass, do it another way around, divide RAM. Okay, right. So we have 1.28 and then we divide by the RM 64. What do we get? 0.02. Okay, I clean it up first. Okay, this one is 0.02 mole. Can we straight away use this? Actually cannot, because we don't know about this yet. Okay, so we find this first, it, right? So 2AgNO3, okay, is given the, okay, for the AgNO3, you can find the molarity and also the volume of it. So if you have the molarity and the volume, you can know the mole of it. Okay, so I say the molarity is the mole divided by the volume. The volume here is 100 cm cube, which is 0.1 dm cube. Okay, and that is equal to 0.5. So what is the mole for this? Of course, you multiply this one to here, and then the mole is actually equal to 0.05. Okay. Okay, here will be the problem. If you see got two different mole, right? This one and this one are not the same. Then which one we are going to use? Like just now, both of the mole are actually equal. But for this case, both of the moles are not equal. One is higher, one is lower. So normally, if you see this kind of case happen, okay, if you see this case happen, we'll use the lower one. Okay, the higher one is actually excess, which means got too much. Some of them they didn't react, so we didn't use this one. We used the lower one. Okay, so for the ratio, okay, this one is 1, this one is 2, and this one is 2. We use it 1 to 2. Okay, it's actually 1 to 2. So now what we have? 0.02, right? 0.02. So in 1, it becomes 0.02. 2 also multiplied by 0.02. What do we get? 0.04, right? So this one is actually the mole of the silver. All right. So let us continue. Okay, so now we already have the mole of the silver. It will be very easy for us to find the heat. Okay, so negative 105. Q is divided by 0.04. So this one multiplied by this one. I remove the negative first, it will for easier for us to calculate. Okay, so 105 multiplied by 0.04 is Q. You can see Q is equal to 4.2. In what unit? kJ. Right, because it's kJ here, kJ here, so we use kJ. Okay, now you already find the 4.2 kJ, and then we write it in joule. Is 4200 joule J. Okay, so you can see Q is 4200. Q is also 420 theta. So we relate these two together. 420 theta is equal to 4200. Okay, for theta, how are we going to find? Of course, we divide. Divide by what? 2400. If you move this one to this side, 2400 divided by 2400, it will be equal to 10. So this is the final answer we want in degrees Celsius. Right? Can everyone understand? Guys? Can you all understand how did I do it? Right, sure. All right. Let me continue with the next question. Okay, the next one is the heat of neutralizations. Okay, the heat change during a neutralization reactions. This one is S, not Z. Z is actually the American's word of neutralizations. So it will show that my spelling is error here, but actually it's not. Neutralizations, reactions between HCl and LiOH is shown in the following thermochemical equations. Okay. Calculate the temperature change when 250 of 0.1 blah blah. HCl is mixed with 200 cm³ of 2.0 mole dm³ lithium hydroxide. All right, like the question just now, we are finding the the temperature change, which is the theta. So still the same, we write out the formula first. Q equal to mc theta. Right. Let's see what do we have now. All right, the Q is equal to mc theta. So now we have 2 cup of solutions. The first one is this one, and the second one is this one. So for the mass, how are we going to find? Can anyone tell me? Anyone tell me? So now we have 2 cups with different volumes of solutions. How are we going to find the mass? I just said just now, the mass is actually equal to the volume. So the volume given is 200 and 250. Can anyone tell me how do we find out the mass? We got 2 here. How? Just now we only got 1. Anyone can give me the answer inside the chat box? Guys? How are we gonna find the mass of the solutions? All right, never mind. I do it myself. So basically, we have 2 mass here. We have 2 volume here. So the volume is equal to mass. So how are we gonna find? Basically, we add up. We sum up 2 of them. So 200 add up with 250. Okay. And then the heat capacity is given 4.2. And the temperature change is not given, that we need to find. So we keep it here. The Q we don't know yet, so we write. Okay, so we continue. 200 plus 250. Okay, 200 plus 250 is 450. And then multiply by 4.2. Then multiply by the dot. Okay, type it into calculator. 4.2. It's 1890. So here is the value of Q. Okay. Sorry. theta. I forgot the theta. Okay, so let's continue. Okay, for the second formula, delta H equal to Q over N. So what information we have now? We have the delta H already. So this one is the delta H, right? It's given. So 57.3 is actually equal to the Q, which is the heat. The heat divided by the mole. The mole of what? The mole of, in this case, the mole of water. Like sigma, the heat of the transitions is dividing with the mole of water. Right. So how are we going to find the mole of water here? Still the same. We got two. We have to find out the mole of this one and this one. Right. So for the mole of HCl, okay, like the method I used just now before this, HCl is 0.1. Is the molarity is equal to the mole divided by the volume. Volume is 250 in centimeter cube. Now we have to convert it to dm cube. So we divide, divide by 1,000 is 0.25. Right, so the mole, this one will multiply by 0.1. To the mole is equal to 0.025. Right. 0.025. Okay. For the second one, for the lithium hydroxide, we're going to find using the same method. Okay. The lithium hydroxide here. Okay. So now we got okay, did I make some mistake here? Wait, I think I missed some mistake in the questions. Oh, sorry, a mistake. This is actually 1.0, not 0.1. Sorry for the mistake here. So we try to calculate this one again. Okay, so this will be easier lah. Now we have, okay, 0.25 multiplied by 1. So we got 0.25. This one is our mole already. So let me change the answer a bit. Okay, 0.25. Okay, for the lithium hydroxide, what is it? Okay, so basically this one using the same method. Okay, mole of LiOH, lithium hydroxide, is so the molarity is 2 equal to the mole divided by 200 centimeter cube. We change it into this dm cube is 0.2. Okay. Now the m is equal to this one multiplied by this one is basically 0.4. Okay, so this one is 0.4. Okay, I said just now, we will be using the lesser one because this one will be excess. We'll be using this one, 0.25, to find the mole of water. Now, let's check out the ratio first. The ratio of HCl to water, H2O, is 1 to 1. Right? There's nothing in front, so it basically is 1. Okay. So when we got 0.25 of HCl, so what we will have at the water? So both sides we multiply by the same number, right? So 1 multiplied by 0.25, 1 also multiplied by 0.25 is also 0.25. Right? So this is the mole of water we have. Okay, so we already get the mole. Now we continue with the questions to find the value of Q. Okay, so now we have Q equal to 0.25. Okay, now we just move this to multiply by this. Can anyone tell me the answer? Can anyone tell me? Okay, so basically now we have to find Q is equal to what? So what is the value of Q? Can anyone tell me? Wait, okay. Okay, 14.33, right? Hey, I did make a mistake here. Okay, wait. Okay, right, sorry. Okay, so the answer here you can get it is this one. Movie here is okay. Is 14.325. All right, now we have two value of Q already. So this one is the value of Q, and this one is the value of Q in terms of the temperature change. So we relate these two together. 1890 equal to 143. Okay, sorry. 25. So we relate these two together. Oh, sorry. This one we have to convert to kJ. We have to convert to joule first. So if multiplied by 1,000 is 14,325 joule. Okay. So multiplied by 1,000 is, sorry, it's 14,325. Okay, so this one we divide by this value. So theta is equal to what? Sorry, I think they will be a bit messy. Okay, this one is 14,325. So how can we find this? With both sides we divide by the same value, 14,325 divided by 1890. So the answer we can get is what? Can anyone tell me? 7.579. All right. Let me try it. Okay, good. 7.579 joule. Sorry, in degrees Celsius. So this is the final answer we have. Right? Guys, can you guys understand? Can you guys understand this one? Because I feel like it's starting to be a bit complicated already. For the next questions, I don't know. I just want to know, can you guys follow? Yeah. Alright. Okay, let's continue with the last one. Okay, this one is the heat of combustions questions. Now okay, I read the questions first. When ethane reacts with steam under certain conditions, ethanol is produced. Actually, ethanol is known as a clean fuel because it burns to produce carbon dioxide and water without other pollutants, right? So basically, in these questions, it's nothing with ethane. It's only with ethanol only. This is the point one. Okay. So questions A, construct an equations for the combustions of ethanol in excess oxygen. For this one, is a bit off topic, but this one is actually a part of Form 5 Chapter 2. Okay. Combustions of 0.92 gram of ethanol increase the temperature of 500 cm³ of water from 30 to 56 degrees Celsius. Calculate the heat of combustions of ethanol. And the last one is draw the energy level diagram. Okay, for this one, right? Okay. This one will be a little bit different. Okay, let us do the question A first. Construct the equations of the combustions of ethanol in excess oxygen. So what do we have here? Ethanol plus oxygen become what? It already tell you become only produce carbon dioxide and water. So become what? Carbon dioxide and water. So the only question here is, what is the chemical formula of ethanol? If you know, then okay, like for the, what is the basic formula for ethanol is Cn, then H2N plus 1, and then OH. But if you don't know, it's never mind. You can draw it out. So basically ethanol, right? It means you have two carbon. and then just fill it with hydrogen. Okay, and one of it is oxygen and hydrogen. Okay, so how many we have? So C is 2 definitely. Okay, H is what? 1, 2, 3, 4, 5. H is 5, and OH is definitely 1. So this is the formula of ethanol. Okay, ethanol is C2H5OH plus the oxygen. Oxygen very easy, O2. And then CO2 plus H2O. Okay, the second thing here is to balance. How are we going to balance this? Okay, from the easy one, you can see, okay, the carbon, we only have 2 carbon here. So now, the left side, you have 2 carbon. The right side, you also need to have 2 carbon. So this one, we will 2. Okay, for the... Okay, now check out the oxygen lah. Oxygen, how many we have here? 1, 2, 3. And this one, we have 3 also. Okay, never mind. Hydrogen. We have 5 plus 1, 6 hydrogen here, but we only have 2 hydrogen here. So now we have to multiply the whole thing by 3. 3, 2, 6. Okay, so the hydrogen is balanced already. Now what can we do with the oxygen? Okay, oxygen is, we have 2, 2, 4 plus 3 is 7. 7 plus, how many have here? We only have 3 at here. So this one, 3 multiplied by 2, we got 6. 6 plus 1 is 7. Now, like this form, this will be balanced. Yeah. So for question A, we already done. Okay, let's continue with questions B. But I think I have to clean up my screen first. Wait. All right. Wait for a while. Okay. So I will write the formula again. 5OH plus O2 become CO2 plus 3H2O. Okay. So we continue with question B. Okay, combustions of 0.2 ethanol increase the temperature of water. Okay, so now we have to find Q first. Q equal to MC delta. So we do with this formula also, but this time there will be a little bit difference. Okay, you can see the mass of ethanol here, but we are not using this one. We will be using the mass of water or the volume of water because the volume of water is equal to the mass of water. So we continue. We will be finding the water one. Okay, water is 500. Okay. Multiply by the specific capacity is 4.2, right? It's given here, right? Okay, multiply by the temperature change. Temperature change is from this one to this one. So 56 minus 50 is 26. Okay. So let's check the answer. So basically, you multiply everything together is 500 plus 4.2 plus 26. Sorry, multiply plus 4 times 2 multiply 26. Okay, is 54600. All right. Now we already got the Q now. Okay, so let's continue with the delta H. Delta H equal to what? Q over N, right? The N we have to use here is the mole of the ethanol, which is the alcohol. So what N will be? What is the N here we'll be using now? So let's check what information we can get. So we got the mass of ethanol and the molar mass is given. So now this means we can find the mole of the ethanol by using the molar mass. So we know that, right? Mole to mass to mole is to divide by the molar mass. In this case, the molar mass is the relative molecule mass, RMM. So what is the RMM here? Okay, you got C. You can see, okay, C we have 2. So C is 12, right? 12, we got 2 here, multiply by 2. And then add up with what? Hydrogen got 5 plus 1, 6. So 6 multiplied by hydrogen is 1. 6 multiplied by 1 is only 6. And then we got oxygen is add up with oxygen is 16. Okay, so we try to find this. This will be the RMM. 12 times 2 plus 6 plus 16. So it's equal to 46. This is the RMM one. Okay, now we have the mass, right? 0.92. We divide by 46. It will be equal to 0.02. Right, so after this, everything will be easy. So the delta H equal to what? The heat is this one, 54600, but we have to convert it. Still saying we have to convert it to kilojoule. This one is joule. We have to convert it to kilojoule. It's 54.6 kJ over the mole of the alcohol is 0.02. So what is the final answer? Right, you guys calculate for me. Type inside the chat box. So tell me the final answer. Guys, anyone type the answer? Okay, already see it. Nice, thank you. Okay, 2730. But still the same. You have to write it again with the unit. Okay, so before we write the unit, this one is endothermic or exothermic. When you can see the temperature increase from 30 to 56, which means it is exothermic. Exothermic means what? The delta H must be in negative. Negative 2730, and then with the unit of kilojoule mole to the power of -1. Alright guys, understand? Alright, okay, let's proceed with the last one. Draw the energy level diagram. Okay, this one is very easy, so we just need to draw it out. Okay, can I clean the space for me to draw? Where can I draw? Or maybe I open a new slide. Can I do like that? Sorry. Okay. Okay, for the last one, the energy diagram. Very easy. First, you draw the vertical line. Of course, sorry, I think I can draw using sheet. I need to use my pen. This one. Okay. So, first step, draw an arrow. This one is the vertical axis. And then, insert another arrow. Draw another arrow, like, sorry, not another arrow. You draw a straight line. Horizontal line. Okay. Now for the exothermic reactions, right? Like I said just now, the energy content inside the product is actually lesser comparing to the reactants. So that means this one is our energy level. Our energy level will decrease after the reactions happen. So when we decrease, right, the final one will be lower than the initial one. So we draw something like this. Okay, good. And then we draw an arrow to show it is decreasing. Yeah. Draw an arrow from here to here. Okay. Now we know this is decreasing. And also we label this one. Insert text. And then I just write apply. So this one is the energy. Okay. And this one also. Okay. Now here is the place that we have to write our equations. So C2H5OH with oxygen O2, and then the product is 2. Sorry, this one is 3 because I forgot to balance. CO2 plus 3H2O. Okay, and then here is the place that we have to label our heat of reaction, delta H. Okay, what answer we have just now? 2730. By negative. Negative 2730 kJ mole of -1. Okay, so this one will be our final answer lah. Okay, everyone can get it, right? Guys, understand? Okay, I can see some reactions there. All right, I think that's all of my class lah. Thank you guys for joining. I end this early because I already finished what have I gonna teach for today. So thank you everyone for joining. See you guys next time. Right.
Terima kasih kepada Guru Muda Maya SMK Taman Maluri YPC kita pada malam ini. Ucapan terima kasih juga diucapkan kepada Guru Pembimbing Cikgu Nur Syahira. Tidak lupa juga kepada rakan-rakan yang sudi bersama kita secara maya. Berharap rakan-rakan memanfaatkan ilmu yang dikongsikan sebentar tadi dalam peperiksaan SPM nanti. Semoga berjumpa lagi. Assalamualaikum warahmatullahi wabarakatuh. Selamat sejahtera dan terima kasih.
Do I need to sign up for the cardi run? Thank you, thank you. Thank you for joining. So can I leave the meeting?